You got the record?
It's recording.
Great. Thanks everyone for coming. I'm super excited about this because it's fun to be in this kind of space where we're all like ready to have a conversation. And also it's fun that there are so many different disciplines in the room. This is a project where we draw on some ideas in some neighboring disciplines, and it's possible that you have some ideas about how to tackle these problems that we haven't thought of yet, because you have such a variety of perspectives. So if so, we would love to hear about it. This project is together with Soon-Hong Cho, who's a political science PhD candidate at UCLA. And Soon-Hong has done a bunch of work on this project. So it's really our project together, even though I'm the one standing up here today. So our project is motivated by a pretty simple idea. The idea is that there are some outcomes that exist only for some people. So if you think, for example, about hourly wages, only people who are employed have an hourly wage. If you ask someone who was not employed what their hourly wage was in a survey, they might not really know how to answer. They might say like, well, maybe it's zero. I don't know, I earn $0 every week and I work 0 hours per week. It's sort of 0 over 0. It's not clear what your hourly wage is if you're not employed. Only married people can report marital satisfaction. So you could think about like, how does like getting a new job affect people's happiness in their marriage? Well, maybe that also affects whether the marriage survives or not. So that for some people under one of those conditions, they just don't have an outcome. In intergenerational mobility, we might think about how only people who have children can have descendants. So if I asked a question about like, how does some experience in my life affect the probability that my child finishes college? I would be conditioning on the fact that I have a child, and that might itself be a consequence of the thing happening in my life. So for many outcomes in sociology and demography, we can often think about them as existing only for one portion of the population. Now this matters because you can think about how inequality could be obscured if we just restrict attention to the outcomes that exist. So as a concrete example to have in our minds, let's imagine we are in a small town and there's a problem of non-employment in that town. So we have 4 people living in this town. 2 of them are employed. They earn $20 and $30 per hour. And 2 of them, they are not employed. So their wage outcome does not exist. We now might imagine a counterfactual scenario where a new factory opens in that town. And when the new factory opens, these 2 people who would otherwise have been employed, they actually end up earning more money. And the 2 people who would otherwise have been non-employed, they enter the labor market. What's puzzling here is that if you compare the left and the right, we have a mean wage on the left, $25, and a mean wage on the right that is also $25. And it might appear that nothing has really changed. But as demographers, we can see that like the population has changed. There is a population of 2 people here and a population of 4 people over here. So at a high level, what we're doing in this paper is thinking about how this entry and exit of people from a population as a function of a treatment can change our measures of inequality in that population. Now, we aren't the first to think about this problem, so I'm going to quickly talk about 2 approaches that are very popular in different literatures, and ultimately we're going to focus mostly on the second approach. So let me start with the first one, is this Heckman selection correction. So if you are an economist, you have learned this in econometrics. You've learned the idea that we could study how does a factory opening affect pay. And we might assume that actually all people, in this case, all 4 people in either condition, they have like an offer wage. This is like the wage that the labor market offers to them. We then see that offer wage if the person becomes employed. So if they accept the offer, then we see their wage. And if they don't accept the offer, then we don't get to see what that wage would have been. And so this solves the problem because it says, well, actually there is an outcome for all 4 people in either condition. And what we need ideally is an instrument that affects employment, but does not directly affect your offer wage. And in that case, you can see how there's some people who are not employed, but we can find people who are just like them, but have a different value on the instrument, and thus they are employed, upweight those people, and draw inference about the whole population of people. In this project, we are not going to go about it from this approach. A couple of reasons. So one reason is that we often don't think this kind of an instrument exists. The kinds of things that expect the values of an outcome often also affect whether that outcome exists at all. The other reason is that this requires us to think philosophically about this sort of theoretical wage that someone would have if they were employed. And that gets harder to do in some other kinds of questions we might have in demography, where it's not so much like you accept the wage or you don't accept the wage. The approach we are going to follow in this project is called principal stratification in biostatistics and epidemiology. And so this approach is motivated by what you could think of as a randomized controlled medical trial. So we enroll a bunch of subjects in a trial and we randomize binary treatment, like some new experimental drug. We then see after some period, when we follow up with the people, do they survive or not? So S equals 1 for those who survive, S equals 0 for those who don't survive. We might then also measure some numeric outcome Y, so like blood pressure at the time of follow-up. And you can see how this has kind of the same structure, where your blood pressure is a value that only makes sense if you have survived. Like if you haven't survived, maybe your blood pressure is 0, but that's a little weird. It's like kind of hard to think about. It's also hard to do the Heckman thing in this setting where you say like, oh, well, someone would have chosen to survive if their blood pressure were offered at a higher value or a lower value. So like when you move to these questions, that becomes hard to do. In this framework, there are 2 quantities of interest. So the first is the average causal effect of the treatment on the survival rate. And then the second question is the effect on the outcome, in this case, blood pressure, among this subgroup of people who are those who would have survived in either condition. Something you might like about this is that it partitions the research question into kind of 2 components. Like first, we should see how a treatment affects the existence of outcomes. Then among those who would have an outcome either way, we see the effect of the treatment on the outcome value. The drawback of this approach is that at the end of the day, we're always going to set identify parameters instead of point identifying parameters. So we're always going to give a range of possible values instead of one particular value. Okay, so what we like here is that we don't have to do this philosophical offer value of Y that's sometimes hard to do in some settings. And we also like that there's no instrument required. Okay, so our project is to do principal stratification in a setting where we're going to adjust for measured confounders. So this might seem like kind of a small step forward. I'm going to spend most of the talk actually talking about principal stratification because you kind of have to understand the concepts in order to understand the small step we take beyond that. The small step is how to adjust for confounding through this strategy of a regression model and then a simulation. I also don't know the norms for questions here. Should we interrupt if there are questions?
If you're open to that.
Totally. Anyone want to throw one out there before I keep going here? Dennis.
Why is it called principal stratification?
You know, I actually don't know like the etymology of it. The idea is that there are principal strata defined by the potential outcomes of the survival variable. So similar to how like with an instrument, there are 4 strata. There's like the instrument randomizes and then that affects whether people are treated. And there are some are the always takers, some are the never takers, some are the compliers who get induced by the treatment, and some are the defiers who don't take the treatment. That is an application of principal strata. So there are these 4 principal strata, principal in the sense of like the important ones. I don't know, does anyone know? No. Okay, going once. Okay, hands up at any point if you want to clarify anything. Okay, so we are going to deal with this setting where a treatment may affect outcome existence and outcome values, and there may be unobserved confounders that affect outcome existence and outcome values. So like all the things that would affect your employment and also your wage, for example, we're going to allow those things to exist in our framework. Okay, we're going to illustrate this in a concrete setting. So our concrete setting is the motherhood wage penalty. We are interested in how parenthood affects the hourly wages of men and women. This is a widely studied topic in sociology. There's some evidence that the entry into parenthood reduces hourly wages for women and increases or leaves them the same for men. And thus, the effects of parenthood create gender inequality in the labor market. There's also some recent evidence that the motherhood wage penalty may be declining over time. So some studies suggest that the effect of motherhood on wages is like getting closer and closer to 0. And to preview results, we're going to show that under our approach, the estimates are actually consistent with a truth that's close to 0 or a truth that is still quite negative. So we're not going to be able to pinpoint it, but we're going to say the range is bigger than you might think given past research. We're going to construct our data in a particular way that is amenable to our design. So we have 4 parents. We're going to think about an observation that's going to be the pre-parenthood observation. That's an observation that has happens 9 or more months before first birth, and a post-birth observation, which is 12 or more months after the first birth. I forget what our max on that distance is, but it's like within a year beyond that cut point. We then make a similar set of observations for non-parents. So these are either people who never have a child or have not yet had a child as a post-observation. And so for them, we have a pre-observation and a post-observation that are spaced the same amount of time as we had for the parents. So the reason for doing this is we can now think about how to make a comparable set, parent and non-parent observations, where the parents are treated units and the non-parents are untreated units. This is, I think, pretty simple, but it's unusual in this literature. So any clarification, feel free to, hands up. Is anyone back?
Yeah, sorry, I missed the first half of the presentation, but for the parents and non-parents, like, is there anything you use to control the two sets so that they are comparable with certain variables?
Yes, so ultimately we're gonna use regression to adjust for education, marital status, age, work experience, job tenure, and enrollment in school, I think. So how do most researchers study this question? Most researchers studying the motherhood wage penalty begin by arranging their data set, and then they estimate a regression model. So in order to estimate the regression, they make the outcome log of hourly wage. And they typically begin by dropping the cases of people who are not employed. So some people will impute a low value for the wage. There's various approaches, but I would say the most common is just to drop people who are not employed from the analysis. Then people fit a regression with a bunch of predictors. So there's a coefficient beta 1 on mother, and then a bunch of coefficients on these other control variables. Researchers will then interpret the coefficient beta 1 as the motherhood wage penalty. Now, a reason this might seem unsatisfying to us is that this does not allow the possibility of effect heterogeneity. So this regression assumes that that beta 1, it applies to everyone equally. You notice there's no interactions here between the treatment and the other variables. Something else that I find unsatisfying about this is that there are no potential outcomes here. So nothing about this is inherently causal. This is just a best linear approximation to some conditional expectation function. So instead of this approach, we're going to proceed in the potential outcomes framework, which is going to take some build-up for those who have not seen the potential outcomes framework before. Okay, so I'm going to explain this approach through a hypothetical example of 4 women. These women are going to be like identical twins. So you can imagine them all looking exactly identical on pre-treatment variables. So in the pre-period, they have the same education, same marital status, same work experience, same age, same job tenure, etc. The first woman is Maya. So Maya has a couple potential outcomes. If Maya were a mother, then she would be employed. If she were not a mother, she would also be employed. This means that the effect of motherhood on employment for Maya is 0. She'd be employed either way, the difference is 0. Now, if Maya were a mother, she would be paid $30 per hour. If she were not a mother, she would be paid $40 per hour. So the causal effect of motherhood on Maya's hourly wage is minus $10. So here we have 2 potential outcomes, and a difference across those potential outcomes defines our causal effect. Okay, so now let's think about Mia. Mia is going to be just like Maya, but with a few key differences. So if Mia were a mother, she would not be employed. If she were not a mother, she would be employed. Thus, the causal effect of motherhood on employment for Mia is minus 1. Motherhood induces her into non-employment. Now, for her hourly wage as a mother, it's like not clear what her hourly wage would be because she's not employed. She's one of these people who, if we ask them in survey, she would say, well, I don't have an hourly wage, I'm not employed. Now, if she were not a mother, she would have an hourly wage, $20 per hour. And so the causal effect of motherhood on hourly wage for Mia is kind of an undefined quantity because it's the difference between an outcome that doesn't exist and $20 per hour. So we have Maya and Mia. Let's assume they also have identical twins, Nancy and Mia. So all 4 women, they're identical on these pre-treatment variables. The only difference between the rows is that Maya and Nancy share exactly the same potential outcomes, and Mia and Mia, they also share the same potential outcomes. But along pre-treatment variables, they would all look exactly the same. Let's further assume that Maya is a mother, and Mia is a mother, Nancy is a non-mother, Mia is a non-mother. So now we get to start to see which of the potential outcomes we actually observe. So for Maya and Mia, they are mothers. So what we would see in data is their outcome as a mother. Nancy and Mia are non-mothers, we see their outcome as a non-mother. And thus, we would see the situation that researchers would face when they normally structure their data set using realized random variables. They would say, well, Mia is a mother, but she's not employed, and I'm gonna just drop the people who are not employed from my data set. And this should all be fine because, Maya, Nancy, and Mia, they're still identical twins along all these measured variables. Then the researcher says, well, okay, among the mothers, the mean hourly wage is $30. And among the non-mothers, the mean hourly wage is $30. And so this researcher then concludes that the motherhood wage penalty is 0. And you can see what the problem is here. The problem is that the researcher's choice to drop Mia, that is like a selective choice. Mia is dropped as a function of her potential outcomes. And in fact, if we wanted to make a fair comparison, really we should compare Maya to Nancy, and we should drop both Mia and Mia from the analysis. But you can't just do that because you don't know that Mia would not have an hourly wage as a mother. You only see her outcomes as a non-mother. And so this is like the fundamental problem we face, is that when we drop people who don't have an outcome, we end up creating an apples and oranges comparison where some people don't have an outcome because of the treatment, and this can produce misleading results when we look at the distribution of outcome values. Pause for questions, hands on this. Okay, so this is the fundamental problem that we sort of set out to try to solve here. So what should we do? We think there are two causal estimates that are of interest and that we could go after in this analysis. The first is the average causal effect of motherhood on employment. Equivalently, this is the effect of a treatment on survival. So often I'm going to use S for employment because more generally this is the survival or the existence of an outcome. All of the people have those potential outcomes. This can be averaged over the whole population. The second causal question is the average causal effect of motherhood on wage among those employed regardless of whether they are mothers or not. So in the medical case, Maya and Nancy are the people who would survive regardless of treatment. And so for them, we would be interested in their outcome. And the key problem is, how do we figure out that Mia should not be part of this comparison set for the second question? Okay, so for goal 1, this will go pretty fast because the effect on outcome existence is really basic average treatment effect estimation from causal inference. So let's define 2 potential outcomes. The superscripts here denote hypothetical treatment values. So S1 is whether a particular woman would be employed as a parent, so under the treatment condition. S0 is whether she'd be employed as a non-parent. The causal effect then for each person is S1 minus S0, and we're interested in the average treatment effect on the treated, which is what's the expected value of the difference in survival under 2 treatment conditions, given that you are treated, given that the treatment variable A took the value to 1. We can identify this just as we do all kinds of causal effects, where we might assume conditional ignorability or conditional exchangeability, depending on your field, where we would assume that treatment A, so whether one becomes a mother or not, is independent of potential employment, S1 and S0, that would be realized as a mother or not, once we look within subgroups defined by the covariance X. So this assumption says that if you have 2 women who are identical on age, education, marital status, work experience, job tenure, etc., and one's a mom and one is not, their choice to become a mom is not a function of their potential employment as a non-mom or as a mom. Once we make that assumption, then estimation becomes really easy. So estimation is just, we fit a regression model to predict survival S as a function of treatment and the confounders X. We then go in and we set everyone's treatment to the value 1 and predict Y hat, because it's S hat 1 for all people. Then set everyone's treatment to the value 0, predict S hat 0 for all the people, difference, and then average over our set of mothers. Yeah, Ted?
How comfortable should we be with that identification assumption? Feels quite strong, but what's your?
Yes, I think This one I actually find like moderately credible because I think people become parents for lots of reasons that are not related to their labor market outcomes. So despite the focus of us in sociology often on the labor market, I think there are lots of things out there in the world that help induce people into parenthood that might be orthogonal to their employment. But I think we should always be somewhat skeptical of this assumption. It's not clear to me actually which direction the bias would go. So this is an open thing to think about. We'll get to other assumptions that I think actually are more credible in this setting. We'll need this one plus some others. And I think the next one is going to be a slightly more credible assumption. Okay, so in our data setting, we estimate that motherhood reduces employment by 14 percentage points. So this is like not zero, it's not huge, but it's enough that it might make a difference where we might be inducing some kind of selection if we look at wage effects only among those who are factually employed. This tells us that 14% of the people are people like Nancy and Mia who would be employed only if they are a non-mother. Yeah, that's.
So I just like survival is clearly like you do or you don't survive. For employment, it seems like you could have a full-time job or you could have, and if your outcome is the hourly wage, are you able to capture sort of like working less or maybe the same way? I mean, does that factor into this or is that not?
Yeah, we actually haven't thought about that. For this, we just say if you have any job, such that if I ask you what is your hourly wage in your job, you can give me an answer, then you count as survived. I'd have to think about how we would think about it differently if S would be categorical in your like full-time, part-time, multiple
or maybe
jobs.
Total earnings or something, yeah.
Totally, yeah. Okay, we're ready for goal 2. Okay, goal 2. The effect on outcome value. So this is the harder goal. So for this, we're gonna have to define some potential outcomes again. So Y1 is the wage that someone would realize as a parent. Now, if you think about that, that's only defined for a subset of the population. That's the people who would be employed as a parent. So only if you would survive in the treatment condition, then you have a potential wage in the treatment condition. Likewise, we have a potential wage in the untreated condition, Y0, and that only exists if your S0 equals 1. So this leads to the causal effect on wage, Y1 minus Y0. Who is that defined for? That's only defined for the subset of people who would be employed as a mother, and they would also be employed as a non-mother. And the whole challenge is figuring out who these people are. So to formally write it, our causal estimate here is the average effect of the treatment on the outcome value, Y1 minus Y0, among those who got the treatment, in our case that's the mothers, whose outcome would exist regardless. So we can see who the mothers are. We never know which of them would have an outcome regardless. We're going to make some assumptions in order to help pin that down. So the first assumption we're going to make is that every employed mom would also be employed if she were counterfactually childless. This assumption is monotonicity. So it says that motherhood may reduce someone's employment, but it never induces someone to become employed. And this is exactly analogous to the monotonicity assumption that is made in instrumental variables, where one assumes that an instrument may increase but never reduce the chance of treatment. Here we assume that motherhood may reduce the chance of employment but never increases the chance of employment. This is helpful. This is the assumption that I think is more credible. You can tell a story in which motherhood induces someone into becoming employed. Perhaps, for example, if like you have like no source of income and suddenly it's very important that you have income, maybe this would induce employment. I think it's for many more people, at least in the US setting, it's the case that motherhood may prevent employment but doesn't induce employment. So this is an assumption, no one knows for sure, but if we buy this assumption, then we can proceed. Okay, so what does this buy us? Well, the first part of our causal estimate was the mean wage under motherhood among the mothers who would be employed regardless of motherhood. Now, that causal estimate is at the beginning pretty simple. So these are all mothers. So when we see an outcome value, we see Y1, the one we wanted. They're also mothers who are employed. So we can see that their S1 equals 1. but we don't know the value of their S0. But by this assumption, if a mother is employed, then she would also be employed as a non-mother. Thus, the employed moms this on the right is the employed moms, tells us about the mean among the moms who would be employed regardless of motherhood. Okay, I'll pause on that if anyone wants me to say it one more time. The next one's gonna be trickier. Okay, ready for the next one? Okay, so the counterfactual wage is harder. So what do we want to estimate? We want to, oh, look at that little note. We want to estimate the mean wage that the parents, A equals 1, would realize if they were counterfactually non-parents. That's y superscript 0. Among those who would be employed regardless, and I've added conditioning on a confounder x here. Once we've assumed the thing that we can match on x and then people are exchangeable, then we can replace this a equals 1 with a equals 0. So now we have the mean wage among the non-parents who would be employed regardless of parenthood. But you see how this is much harder to pin down because the non-parents who are employed, it's very credible that some of them would not be employed if they became parents. I showed you that estimate earlier on that motherhood reduced employment by 14 percentage points. And so these people are going to be a mixture. Within any covariate subgroup, we can tell how big that mixture is because we can estimate how motherhood affects employment within each covariate subgroup X. So let's think the set who would be employed as mothers are this blue group and the others are this gray group. When we look at their mixed distribution of wages, it's a mixture of the two distributions. So some folks in this observed wage distribution, they would still be employed as mothers and some would not. And our task is to separate them into two parts. So what we do, which is what the principal stratification literature does, is we make an extreme assumption. So we first assume that the target subgroup are those whose wages are the highest. Then we assume that the target subgroup are those whose wages are the lowest. Recall that we know how big this blue versus gray portion is because we know the effect of motherhood on employment. And this gives us a range of possible values within every X. Then we aggregate those estimates across the X's and we get our result. This is kind of, I think, uncommon in applied work. Mansky did this a bunch on causal identification, where you set identify instead of point identify. You can generally get it tighter if you make stronger assumptions. So for example, a further assumption for which I'll show you results, but I'm not going to walk through the math of, you might be willing to assume that the non-mothers who are employed, among those people, the ones who would still be employed as mothers have higher average wages than those who would not be employed as mothers. So you might believe this assumption if you think there's some people who are sort of more career-oriented who would be employed in either case, and they would tend to have higher potential wages as non-mothers. That's an assumption that would help you narrow this further and thus tighten balance a little bit more. Yeah.
You probably know about David Lee's work, Lee balance.
Yes.
It's very similar to what
yes.
we would use to call Lee balance.
I think that does not have how to deal with the confounders. But this was one of the papers.
Trimming each, when you have differential selection, trimming the right tail, trimming the left tail, and coming up with the ranges.
Yes. Yeah. So when we first implemented this, we actually did the Lee balance initially.
But here you're doing it sort of covariate subgroup, something like that.
Yes. You've led me into the next point, which is nice. So where this gets hard is if you have a lot of covariates, you actually only see one person at each covariate value. And so the Lee bounds require you to have a whole set of people where, like in a randomized experiment with discrete subgroups, you would be able to do this and non-parametrically just sort the people. But we have often one person at each X. And so instead we fit a regression model to model the distribution of outcomes, conditional on covariates and treatment. We model that, in our case, by a heteroscedastic linear regression. So we basically run OLS, but then we also have a variance function regression. So we parameterize how the spread of these normal distributions varies across X. And this is our overall strategy, is we model survival, we model the conditional distribution of outcomes, and then we basically simulate these bounds that would otherwise be done non-parametrically in the classic principal stratification approaches. So simulate a whole distribution under each treatment condition, lop off the extremes, and show you a range. Is that a
So
question?
just as somebody who doesn't know about principles, so which part of this is not the standard? So number 3 and 4 is a.
Yes, as I read it, the models are not standard.
Got it.
And normally you would use the observed empirical distribution of y. Yes, so I guess actually 4 is the standard part, and 1 to 3 are normally done non-parametrically. Which, like in the medical trial, for sure you do it non-parametrically, because you actually randomize people. You don't have lots of confounders. Yeah. Okay, we ready for results? Okay, so under no assumptions, when we do not assume monotonicity, we're only going to assume exchangeability for these first results. So no monotonicity, no assumption about the relative positioning of the distributions. We have hugely wide bounds. So it could be that motherhood reduces hourly wages. This is log hourly wage, reduces log hourly wage by 0.61 or increases it by 0.6. This is like a 60% effect. Under monotonicity, this becomes much narrower. So motherhood may reduce or increase hourly wages from minus 0.15 to plus 0.14. If we further assume, I guess we do them independently. If we do not assume monotonicity, but we assume that thing about the relative positioning of the wages, we get a slightly wider interval. And then the most informative interval is if you buy all the assumptions, then you get the tightest bounds. This is motherhood may increase hourly wages by 0.02 or reduce them by up to 0.16. We think this matters because in practice, there's this growing literature that suggests the effect may be near zero. And in fact, an effect near zero is within our bounds. But if you believe the assumptions, it's actually also possible there's a considerably negative effect that still exists now. And it's difficult to tease out whether effects have changed or whether these selection processes can make estimates misleading when folks simply drop those who have no wage. Questions? Jonah, you want to say anything?
So this first assumption that Ted raised, right? So I'm trying to think about, okay, how do you think about how sensitive this is to that assumption moving? And is that just about moving the 14% or moving the within the variant subgroup effect on survival? So like, let's say you just assume, let's say I'm 30% off.
Yeah, I think, I don't know if this answers the question, but to me, it's pretty credible that probably the people who are the non-moms who are being included in the standard analysis have higher wages. The non-moms who are being mistakenly included have higher wages than the non-moms who are being correctly included. So like the non-moms who are there because they are not moms and they would stop being employed if they became a mom, I think their wages bring up the estimate of the non-moms in the standard analysis and thus reduce, no, I'm getting twisted around in my words.
I was just more thinking about the process of trying to think about, okay, how would I reflect on how sensitive these are to that first assumption?
Yes, the first, the exchangeability assumption or the monotonicity assumption.
No, the effect that the idea that motherhood is survival.
Oh, yes. So
the idea that there's no confounder there.
Yes, we don't have a good answer to that one. You could think of it as like we're sort of baselining on standard practice that would assume this.
Sure. So anyway, so I was trying to think about how one might bring in that assumption.
Yes, like you would want like a, this is helpful because we could actually maybe do this. Like you would want, do I have the DAG here? No. Assume there is a U that affects motherhood and outcome and wage. How big would that U be? And then a graph for how, yeah, we could do that probably. Also, yeah.
Yeah, just a small question. These estimates, the minus 0.16 and the plus 0.02, those are the estimated effect with one bound or the other bound. But there's a standard error on each of those estimates too. Should that also be represented here? Maybe like that minus 0.16, this doesn't include the standard error on this, right? This is like the mean estimate under one bound or the other. So the actual range might be considerably larger just depending on the precision of each of those estimates.
Yes, I smoothed over this. So the ends of the black part of the bar is the mean point estimate. And then the ends of the whiskers are including the statistical uncertainty.
Okay.
So actually the statistical uncertainty is like very minor compared to the identification.
Thanks for clarifying.
Okay, I will wrap up and then we'll move to discussion. Okay, so we can't point identify. So what we do here is we set identify. This has a long history in causal inference, and I think it's actually something we should do more often because you can see how, like, when you don't make any assumptions, you have really wide bounds. As you make more assumptions, the bounds get tighter, and like the amount of inference you get kind of depends on how many assumptions you're willing to make. This whole approach is based in principal stratification, but I think if you were going to do principal stratification without our paper, you would have a lot of trouble when you have only one person in each confounder subgroup, and you really need a model. So in some sense, what we've done is pretty simple. We just have a model, and then we simulate outcomes, and otherwise we just do this same non-parametric adjustment with our model-based simulated outcomes. More broadly, what we think would be really cool next would be if folks thought a little bit about the kinds of questions where we might miss aspects of inequality because people have dropped those who don't have outcomes. So as an example, like, I have been interested in intergenerational mobility, and I always restrict to the people who have children. But what if I want to know the causal effect of something in one generation on what happens 2 or 3 generations later? There's all kinds of people who don't have descendants 2 or 3 generations later. And that would be exactly this kind of problem, where a treatment actually induces some people into the population or removes them entirely. This happens, I think, in labor market settings. It happens in like family formation settings, like the marriage example. And so there are sure to be more methodological hurdles that come when people tackle these kinds of questions. But we think that's exciting. So if you have other ideas, we would love to hear them for like future areas where we might work on this more. There's my email and there's Soonhong's email, and our paper is on arXiv. That's hard to find. It's also, I put it at the very top of my website today. So if you want the paper, there's an arXiv link there. And we have an R package to help do this to make it easy. And that's what I got.